Shubham Shridhar Nadargi, Assistant Professor, Department of Mechanical Engineering, Walchand Institute of Technology. Today we are going to discuss about natural convection. At the end of this session, student will able to understand how the fluid motion is created for free convection or natural convection. Role of coefficient of volumetric expansion in case of natural convection, Richardson number and Rayleigh number. Now we are going to talk about mechanism of natural convection. Consider a hot plate kept in a cold medium, assuming that temperature of hot plate is greater than temperature of air as a working fluid. Let's say dotted line represent my thermodynamic system. Within that thermodynamic system, I have a T plate, which means temperature of that hot plate, and T fluid as temperature of either fluid, or assuming my fluid is air. In order to know the directional effects, I have taken one coordinate system, that is x along the length of that plate and y perpendicular to that plate. If the surrounding fluid particles touches that hot plate, the temperature of that fluid particle adjacent to that plate will increases. As temperature increases, density of that fluid particle will decrease, which will ultimately create a low pressure zone near the plate of that fluid. Since this low pressure fluid will create a driving force which is moving, all the particle will move in upward direction. So the surrounding fluid particles which are at normal pressure will try to rush towards that plate because of low pressure zone created near the plate. This is the way how the fluid motion is created in case of natural convection or free convection. Regarding the temperature profile, during this mechanism, any particle near to the plate will take the motion of that plate, which is the particle adjacent to the plate, which takes motion of that plate. Means with the help of no slip boundary condition, all the particles near the surface of that plate will acquire the motion of that plate, which is a zero velocity. So adjacent to the plate, whatever the fluid particles are there, these are in stationary condition and will take the temperature of that plate as it is. And based on fluid particles properties, the temperature profile will vary along the y direction as given below. Regarding velocity profile adjacent to the plate, we have no slip boundary condition, which is at the plate we have zero fluid velocity near the plate particles, and we have adjacent fluid particles which are at zero velocity. Within that delta domain, the velocity will vary accordingly from the mechanical principles, which are nothing but one is your no slip boundary condition, and another is at the other end we have one atmospheric velocities. Within that domain only the velocity layer will change, and the boundary layer mechanism for that plate as shown in the diagram. Now role of coefficient of volumetric expansion in the natural convection. Since we know in case of natural convection, density variation of the fluid particles adjacent to the plate will depend upon temperature of that plate and variation of density along that plate. So we have one property which is called coefficient of volumetric expansion, which will ultimately decide the strength of that natural convection phenomena. If beta value is very large means convection effects are significant. In similarly, if beta value is very low or low, then the convection effects are least significant. We know the formula of coefficient of volumetric expansion, which is equal to negative of 1 by rho d rho by dt at constant pressure. Then we have Grashof number. As adjacent fluid particle has motion in upward direction, to show the retardation effect because of viscosity of fluid particle adjacent to that plate will show up retardation motion of that fluid particles. So the Grashof number is defined as ratio of buoyancy force to the viscous force. The dimensionless form number given by g beta delta t characteristic length cube divided by nu square, which is nothing but kinematic viscosity of that fluid particle. Rayleigh number. So the significance of Rayleigh number in given mechanism is discussed because based on Rayleigh number only we can decide whether the fluid motion is in laminar category or in turbulent category. The Rayleigh number is defined as product of Grashof number and Prandtl number. If in case of vertical plates and cylinders, if the Rayleigh number is less than 10 raised to 9, then the fluid is considered to be a laminar flow. If the fluid Rayleigh number is greater than 10 raised to 9, then the flow is categorized under the turbulent flow conditions. After that we have Richardson number, which is denoted by Ri. Ratio of Richardson number is nothing but ratio of Grashof number to the square of Reynolds number. In order to know whether the fluid flow is taking with the help of forced convection or natural convection, it is decided by ratio of these forces, nothing but ratio of this numbers, that is Grashof number or to the square of Reynolds number. If Richardson number is equal to 1, it is the case of mixed convection in which both forced and natural are considered. In case of Richardson number less than equal to 1 or far less than 1, in that case forced convection is in significant role. If Richardson number is greater than 1, then in such case we can consider natural convections are dominant. So friends, these are some of the references for heat and mass transfer subject. First one is Fundamentals of Heat and Mass Transfer, Frank P. Incobrera and David P. David, along with some renowned faculties wrote this book. And we have a textbook on heat transfer by S.P. Sukhatme sir. Thank you.